Good morning, friends. Today also we are seeing problems related with the combined stresses. I think from 2-3 days we started these chapters, and within 2-3 days I will complete these chapters. Means this is third unit. So please note down today's first problems. A short masonry pillar masonry pillar is 600 mm by 600 mm in section. The pillar carries a point load of 100 kilonewton or 1000 kilonewton acting on the centroidal axis of the section shown in figure at an eccentricity of 80 mm from the axis, from the longitudinal axis. Find the maximum and minimum stresses on the section. Both are 600 mm, and this load points, and this is lies on the x axis. So that's why first we will calculate direct stress PO equal to P divided by A, P equal to 1000 kilonewton multiplied by 1000, this multiplied by 1000 for conversions kilonewton to A, Newton, area 600 mm by 600 mm. This is area of cross sections. Divided by 600 square equal to 2.77 Newton per mm squares, and this is compressive. Next, PB equal to, now this PB m by z. In this case, this is Z YY, because this load points on the XX axis, so that's why we requires m into IYY divided by Y max, or Y max divided by IY. This is plus minus, because in the right hand side compressive bending, because this load point is in the right hand side stress, and in the left hand side tensile bending stress. Compressive bending stress means this is positive and this is negative. Plus minus 1000 multiplied by 1000 E equal to 80 Y max, this distance 300, or you can write 600 divided by 2, and this is 600 B equal to 600 divided by 12. Same you can write 600 will get cancelled, and this is multiplied by 600 cube. Divided by and this is equal to 2.22 megapascal. Now sigma max equal to, because this is plus PO plus PB, and this is equal to 2.77 plus 2.22, this is equal to suppose 5 megapascal, and minimum equal to, this is plus minus PB, because this bending stress, compressive bending stress and tensile bending stress, so that's why plus minus this right, this is equal to 0.55 megapascal, but all cases are positive, so that's why you can write PB max equal to 5 megapascal, and this is Pmax, and minimum stress equal to 0.55 megapascal. This is your expected answer. Such type of the simple problem may be asked during the examinations for 10 marks. Now do next problems. Now this is rectangular sections. Suppose this sections is circular section. A cast iron column 750 mm or 250 mm squares in diameter carries a vertical load of 750 kilonewton at a distance of 40 mm from the center of the section. Determine the maximum and minimum value of stresses along the diameter passing through the point loading. In the last problem, the section is rectangular. In this problem, sections is circular sections, but this is solid circular sections. And this load, this eccentricity 40 mm and load 750 kilonewton. And the sections, this is circular section. Suppose this load point P, this is 40 mm. Again, solution, direct stress equal to P divided by A, P equal to 750 kilonewtons multiplied by 1000. This is for convergence, kilonewton to Newton. Area of cross sections pi by 4, 250 square. Or same we can write multiplied by 4 divided by pi, 250 square. 750 multiplied by 1000 into 4 divided by pi. This is equal to 15.27 megapascal. Now, bending stress equal to M divided by Z, M divided by I divided by Y, and this M is nothing but P into E and divided by I multiplied by Y. and this is general. So that's why this is plus minus, because in the right hand side compressive and in the left hand side tensile, and this is compressive. P equal to 750 multiplied by 1000, eccentricity 40, y equal to 250 divided by 2, and this is pi by 64, pi by 64, 250 raised to 4. So that's why we can write this is 750 into 1000 multiplied by 40. This 250 will get cancelled 2, and this is 64, means this is 32 and divided by pi 250 raised to 3. Purposefully I eliminate one step. 1000 multiplied by 40 divided by pi 250 square 4.889. Once again I will check. 750 multiplied by 1000 multiplied by 40 multiplied by 32 divided by pi divided by 250 cube, and this is equal to plus minus 19.556 mega Pascal. Now maximum equal to direct stress plus PB is 15.27 plus 19.556, 15.27, 34.82, and this is compressive, and plus 15.27 minus 19.556. This is equal to 226 megapascal, and this is tensile. So in this case you will get 19.556 megapascal, and this is tensile, and this is compressive. And this is tensile. Now I think you understand problems related with the combined stresses. If you have any doubts related with the combined stresses, you can ask me. Next problems. This is small problem. For the I sections, section given I section, for the I section, beam shown in figure, beam shown in figure, determine the core of the section. Area equal to square and zxx directly given. This is 235 10 to the power 5 raised to cube and 3 into 10 to the power 5 raised to cube. Section given as section. Ten point eight. This is 100. This is equal to 200, and I think this wave also 10.8. Solution. Let Ex means this distance Ex and Ey this distance. Ex be the eccentricity of load this is Ex and this is Ey, right? This is Ex and this is Ey, and Ey be the eccentricity of load from y axis. Now condition direct stress should be equal to bending stress. That's why we can write P divided by A equal to M divided by ZXX, or P divided by A equal to M ZXX or P into E this is X ZX and P divided by A equal to M divided by ZYY. This is section modulus. That's why M equal to P into EY and this is section modulus. This is given. That's why this PP will get cancelled. And you can write ZXX divided by A. Yes, ZYY divided by A or EX equal to ZX 2.235 10 to the power 5 area 32233 EY equal to similarly EY 3 into 10 to the power 5 area equal to again 32 and EX equal to. By using such you can calculate the eccentricity of the load points from the XX axis and from the YY axis. 10 to the power 5 and this is equal to 69.13 mm 3 into 10 to the power 4 and divided by 3 to 9.279 mm. That's why we can draw this is equal to EX equal to 69.13 and this EY equal to 9.279 mm. I think you understand these problems also. Next problem is this problem is I think fourth problem today's. A tie rod a tie rod means this is in between the two poles. Suppose these are the two poles and for avoid vibrations suppose these are the two poles and here's tie rod. This is fixed in between for avoid the vibrations. This is drive on this rotating and here's this may be hunting for avoid that such type of the tie rod can be fitted. A tie rod of uniform circular cross section is required to withstand a maximum tension of 500 kilonewton, but the end of fixing is but the end of fixing is such that the line of actions is of the axis of member by 7.5 mm. Find the minimum diameter of the rod if the maximum allowable stress is 125 Newton per mm squares. First, we'll read problems. A tie rod uniform cross sections is required to withstand a maximum tensions of 500 kilonewton. But the end above the fixing such that the line up of the actions above the axis so step of the tie rod and this force is acting P and this eccentricity equal to 7.5 mm. And what is asked? This is D equal to what? Solution: direct stress P0 equal to direct stress P0 and this is tensile equal to P by A. Load equal to 500 kilonewton multiplied by 1000 divided by area of cross sections pi by 4 and this is d square. That's why I write this is 2000 because multiplied by 4 1000 and divided by pi d square. Let us see what happens. And now in the bottoms tensile bending stress and above the x-axis compressive bending stress. So that's why PB equal to plus minus M by Z. That's why we can write this is P into E. Now section modulus D raised to 3. Because this is solid circular sections. Now, if the maximum allowable stress is 125, because this is tensile and this is, so that's why PO plus, actually this is minus PB equal to 125 Newton per mm square. Because numerically this is correct, right? So that's why we can write 2000 1000 pi divided by d square minus plus PB. P equal to, again, this is 500, eccentricity equal to how much? 7.5 multiplied by 32 divided by pi into d cube equal to 125, right? This is pi d cube, so that's why equation 1 is multiply by pi d cube. That's why this is 2000 into 1000 multiplied by d plus 500 multiplied by 1000, because this is kilonewton and this is eccentricity and this is, and that's why 1000 multiplied by 7.5 multiplied by 32 equal to 125 d cube, right? And this is pi d cube. Otherwise, we can write this is equal to d cube divided by or minus 1000 divided by minus 500 1000 7.5 32 divided by equal to 0. Two hundred 1000 125 divided by, this is 5093 d cube, because this d square 509.3 3d minus this is equal to 305,577. Now solve this equation. You will get D equal to 91.8 mm. I think this is 1 plus and 2 minus. So maximum eccentricity that is allowed is 91.8. This is fourth problem. Now last problem, students. I write here a column (75 mm by 75 mm). Has a circular cavity (37.5) in diameter as shown in figure. Find the maximum value of wear load. Find the maximum value of a load that can be applied at an eccentricity of 10 mm, which with respect to the x-axis in order the maximum compressive stress may reach 80 Newton per m square. Similar type of the problems. I think a column 75 mm, but this is circular and this is hollow. This is circular. Cavity 37.5. this diameter equal to 37.5. 10 mm. (75 by 75), and that's why first solution, direct stress equal to P by A. P equal to area 70 solid minus hollow pi by 4, 37.5 square. Try to understand why this is area equal to solid area minus hollow area. Now that's why 75 multiplied by 75 minus, in bracket I will take bracket, pi 37.5 square divided by 4, bracket close, equal to, otherwise P (37.5) square multiplied by pi and divided by 4. .46, and this is 75 square minus 5625 equal to P divided by 1104 5625 minus 4520.34. Similarly, bending stress equal to M by Z, M equal to P into E into E into Y divided by I. P E equal to 10, Y equal to extreme distance, and this distance equal to 37.5 or 75 divided by 2, 5 by 64 divided by moment of inertia. This is solid minus hollow. That's why P into 100, 37.5 solid 75u into 75u cube minus 5 by 64 raised to 37.5 raised to 4. All right. Here this is P. Total first we'll write 75 divided by 12 multiplied by 75 cube minus bracket pi divided by 64 multiplied by 37.5 square. And divided by answers into 10 multiplied by 37.5. 6772 multiplied by P. All right. Now this is plus minus. So that's why plus we can consider PO plus PB equal to, this is given 80. PO equal to P 4520.34 plus P 6770 equal to 80. That's why P equal to 216.87 kilo Newton. This is your expected answer. Solve these equations by taking LCM. Otherwise, you can take LCM. 6770 multiplied by P plus 4520 P divided by 4520 6770 equal to 80. Now by solving these equations, you will get P equal to 216.87 kilometers. So this is today's fifth problem. In the next class, we will see some of the different problems, means hollow circular sections, etc. Means I think I will conduct more than one class, means maybe tomorrow's class and day after tomorrow's class I will conduct on the combined stresses. After completion of this chapter, we can start another chapters. Another different type of the problems I will engage another 2 lectures, that is on the combined stresses. So that's why today I stop here and we will continue remaining portion in the next class. Thank you.